Um, okay. So last month, some of you asked about puberty and adolescence in with Myhre, the consequences with Myhre. So I'm going to go more about the brain and explain the basics, really basics of what we are going to talk about. And I don't want you to be stressed over that because I'm going to talk about extreme cases or things that can happen with Myhre at the puberty or adolescence, but it's not general to Myhre syndrome patients. So let's start. Maybe some of you recognize I did something on the smartphone and the nervous system a few months ago. So I took some of the slides will be in common with what I talked about already. So just to give you an idea about SMAD4, so SMAD4, that's the mutation we have in Myhre. SMAD4 in the nervous system is involved at different level in the neurogenesis, the neurite outgrowth, the astrocytes proliferation, homeostatic of astrocytes. So I'm going to use some terms that you might hear for the first time. So basically in the brain, you have not only neurons that everybody heard about neurons. So that's the image of a neuron here. That's what we call a nerve cell. And next to the neurons, you have many other cells that are called glial cells. So you have different type. You have the oligodendrocytes that forms what we call the myelin around the neuron. And that's a kind of, if you think about an electrical wire, you have the copper inside, and around it, you have the plastic that allows a kind of insulation. So what we have with the myelin is a kind of insulation, so that the signal, the electric signal will have to jump from one place to another, and that increases the speed of the electrical transmission in the neuron. So those are called myelin, and they are made in the central nervous system by oligodendrocytes, Schwann cells in the peripheral nervous system. There are also other cells that are very important in the brain that are astrocytes, and they are highly regulated by SMAD4, so very important in Myhre syndrome. The other that are very important are the microglial cells. So they are called usually as the immune system cell of the brain. They are also very highly regulated by SMAD4. And those are the cells, that's the first cells we chose as a model for the screening of drugs that we are testing. We took some microglial cells we recreated microglial cells from the patient cells at the origin. So last month I told you, and the month before I told you about the models. So that's one of the model. And the microglial cells are not only the immune system of the brain, they are also stabilizing the synapse between, so the connection between neurons, and they are communicating with astrocytes, so that they are very important in the brain. Going a little bit further, I'm going to use some words during this Q&A. I'm going to talk about spines, dendritic spines. So you need to understand how neurons work. So they have a core, they have what we call dendrites. So the dendrites are going to touch the other neurons around, and the axon is going to conduct the transmission. And at the end, you will have also some synapse, so connection that you can do with other neurons. So the dendrites are like the arms of the neurons that are going to touch and receive information from other neurons. So the connection between two neurons, that's what we call synapse. Okay, is it clear? Do you have any questions? No? Okay, it's clear. So here there is also a kind of schematic drawing on the different interaction between the different cells. So you see that's the myelin from the oligodendrocytes. The same cell can myelin one neuron and another neurons, and they communicate with the microglia, with the astrocytes. So all these glial cells are really fundamental in the process of the brain, and they are highly dependent on SMAD4. Is it okay for everyone? Everyone understands the different type of cells I'm going to talk about and the spines. So the spines, the dendritic spines are important because the more you have, the more you can have opportunity to make new synapses with so new contact with other neurons, which is not always good to have that many contact. Um, so we're going to talk today about adolescence and puberty. We have an hour, so that could be a month, like 100 hours of talking with you. So I'm going to try to reduce and go to the fundamentals. But obviously there is way more to say that what we are going to talk about today. So you know that the adolescence is a period marked with changing in behavior, emotion a lot, and cognition. The main changes are the gonadal hormones, so the sexual hormones that increase at puberty. And in the brain, you see a change in the white matter. So the white matter are the glial cells, and the gray matter that are the core of the neurons. So what you see in the brain at adolescence and during the whole life, in fact, is that there is a change in the volume of the gray matter and the white matter. So you have a linear increase of the white matter, so the glial cells, through the childhood, adolescence, and you have a peak at 30 years old. So you're going to uh, think always about SMAD4. You are going to have SMAD4 influencing the white matter up to 30 years old in Myhre patients. The gray matter, so that's the core of the neurons, is more fluctuating. You have a peak level before puberty, and then it gradually declines after puberty, around 15 years old or even a little bit before. You see a decline of the gray matter volume. So there are different reasons for this decline in gray matter volume. Except in one part of the brain, you can see in red here, where around 16 years old, 15, 16 years old, you have an increase in gray matter. That's a part of the frontal lobe that, in fact, is developed between 16 and 21, 22 years old. And this part of the brain is the part that is going to influence your ability to take decisions, make decisions, take decisions, I don't know, to make decisions and to have a logical thoughts and the ability to organize yourself in life and see the consequences of different actions. So that's a very important part of the brain, and something I want to insist and always say is that if you take THC, so marijuana, during that time, these parts of the increase will not occur or really less. So you decrease your ability to form a part of your frontal lobe, which will influence your ability to make good decision and have a logical to assess the consequences of things and take decision in life. So that's important not only for Myhre, but a lot for all the teenagers. Um, so if you look at the the density of the neurons, if you compare for the child at birth, you have a few neurons. Then at age 7, 8, you have a maximum of neurons. Even at 2 years old, you have a lot of neurons, and then making a lot of connections. And then during life, you are going to select which neurons are going to connect with which neurons. And you are going to reduce the number of connections and the number of neurons. So one of the issue with autism is that you don't have this decrease of neurons. You stay with a lot of neurons. And the decrease of the connection is called pruning. And I'm going to talk a lot about pruning. So that's the basics for understanding what I'm going to talk about for the rest of this Q&A. Going back to uh, Myhre specifically. So Myhre has mutation. Myhre syndrome patient have two type of mutation. Let's say mutation in SMAD4. This protein is a transcription factor, which means that it's going to trigger expression of other genes in the nucleus, but it can go in two directions. One, in making a kind of complex with other SMAD proteins, which are the SMAD 1, 5, and 8, or go to SMAD 2 and 3 and make a complex and then go to the nucleus. So there is already an issue here with a kind of competition between going to SMAD 2, 3 and going to SMAD 1, 5, 8. So the issue with Myhre syndrome is that you see it's a multisystemic. You see a lot of different manifestation because in fact SMAD4 is at the end of communication to the cells with different what we call ligands. And this superfamily is called the TGF-beta superfamily. And you have different type of molecules that can communicate to the cell and tell SMAD4 to be activated. It's the TGF-beta, the bone morphogenic protein, activin and inhibin nodal, and something that is very important that I'm going to talk about a lot today is the anti-Müllerian hormone. So the anti-Müllerian hormone goes through SMAD158, binds to SMAD4, and then makes a complex with SMAD4, and then goes to activate targeted genes. So this anti-Müllerian hormone is important in the brain and is important in, it's a sexual hormone, so it's important also in at the puberty, in the cycle of sexual hormone, the AMH, so that's the anti-Müllerian hormone, if it works properly, is going to equilibrate the ratio of sexual hormone coming from the brain, that's the hypothalamus and the pituitary glands. So it will equilibrate this ratio if it works properly, and then this will, the lutein hormone and follicle stimulating hormone, this ratio is going to determine the ovulation and the quality of the uterus endometrium. So if you have an issue with the AMH, the anti-Müllerian hormone, if you have an issue with SMAD4, you will have an issue with the anti-Müllerian hormone, and that will trigger an imbalance in the lutein hormone and follicle stimulating hormone. So you can have what we call PCOS with different modification of the endometrium and the ability to have an ovulation. Something that is also very important is that the AMH, the anti-Müllerian hormone, act on the aromatase, And the aromatase is an enzyme that is going to transform estrogen and into testosterone. So that's also important for male because we will have a problem also in the androgen production. Here it's in ovary because that's a scheme for PCOS. But there will be also a discrepancy in the testosterone production for male if you have an issue with the AMH. Is it more or less clear? Do you have any questions? Is it too difficult? Just give me some feedback. It's okay? Okay, so then I will.
It's okay.
Okay. So I'll go on with the anti-Mullerian hormone. So this is an hormone that acts on the ovary, on all the sexual parts, but on many other parts of the brain. It's peripheral in the brain, but also in the peripheral system. So it's a growth factor for motor neurons. It inhibits osteoclast differentiation, so it acts on bones, and it acts on testosterone, as I said before, but it acts also inside the brain because you have the AMH that can be secreted by ovaries and the sexual part of the body, but it's also synthesized in the brain. So AMH, the anti-Mullerian hormone, has been linked with autism, especially in boys. We saw that there is a discrepancy between the AMH in boys with autism and without autism. So you can imagine that in the Myhre syndrome with AMH going through SMAD4, you will have an action on autism. You will have a densification of neurons in early life. So there are too many neurons. There is a neuroprotective effect, but if you have the SMAD4 that is not working properly, then do we have that or not? We don't know yet. So and what was shown is that an increase in anti-Mullerian hormone level is connected with the worse episodic memory, reaction time, reduced reasoning scores, but it doesn't have any influence on the executive skills. So if you tell someone with AMH issues to do something, they will do and they can do it properly. So that's not, well, from two different studies. So all that has to be confirmed more and more. So going back to the really purely the AMH and the puberty, so it's involved in the formation of reproductive organs, sorry, during the embryology, but also after at adolescence, as I just showed you before. There is a reproductive function, and in PCOS, so polycystic ovary syndrome, sorry, I didn't say it before, not in Myhre, but in general, generally in patients with PCOS, we see an increase of the AMH in the blood. So thinking about SMAD4, if you have a gain of function, then it's logical that you have PCOS also. We see Oh, sorry. I don't know why my Zoom just kicked me out of
Yeah,
the.
you cut out very briefly. When you stopped, we had just gotten through. Oh, goodness. Can you
Oh, I think
keep
someone
the
is
light on?
Barkan, can you mute yourself? Uh,
Wow.
What a morning. You had just
okay,
been through
thanks.
explaining a little bit about PCOS, so if you could just go back maybe a minute or two.
Okay, so I was here, or did you see that?
Whoops.
Here.
This is what we saw. Yep.
Yeah,
Okay,
yeah.
Thank
So
you.
okay, so did you hear about the AMH influencing the migration of neurons in the hypothalamus? No.
no.
Um, okay, so we talked about PCOS, that was the former slides, but the AMH has a lot of action in the brain and notably in the hypothalamus, in the pituitary glands, and the hippocampus that are um, different part of the brain that I'm going to describe. I see that there are a few people coming in now. I don't know if I need to go back a little bit or what do you think, Christiana?
Sorry, I was on mute. I think a few people have had connection issues this morning, but I'm letting folks in. I know Karen was here when we started, so
Okay,
I think
okay,
you're probably in an okay spot.
okay. So I was just saying that the AMH is act on the peripheral system, so in bones, in motor neurons, on the sexual organs, but also really in the brain, and in very particular part of the brain that are the hypothalamus. So what we the hypothalamus, thalamus, and pituitary glands, and basically what a part of the brain that we call the diencephalon. But AMH also acts a lot on hippocampus, which is a part of the brain that is involved. I will talk later in emotions and different psychosis. So the AMH, the anti-Mullerian hormone, goes through a receptor, and if you look at where this receptor is expressed in human, so you have the brain. It's yellow and white, so you can't really see it. But in the brain, in the pancreas, in the ovaries, of course, testes, stomach. And in the adrenal gland. So it's also very important for stress related action. Um, so let's go to the brain because puberty and adolescence, that's the sexual hormones. So we just saw for PCOS and testes, but it's also a lot change in emotion, cognition, and behavior. So there's a part of the brain that is called the hippocampus. It's here in the brain, and it helps to form new memories or recall past experience. It plays a key role in spatial awareness and navigating environments, and it also helps to process emotion and map with social connection. So that's really for the special awareness. I'm not sure it's really important for the teenagers, but the process emotion and map social connection. That's really a fundamental change that you see at the teenagers and at the puberty. And fun fact, in fact, you see in autism people, they have quite often the special awareness and navigating the environment is an issue for people on the autism spectrum disorder. So going a little bit deeper, in what happens in the hippocampus at the puberty is that I showed you at the beginning that you have a lot of neurons, and then you are going to slowly decrease the number of neurons, and you are going to reinforce certain connection between certain neurons. So this elimination of connection with other neurons and decrease of the volumes of the gray matter is partially due to synaptic pruning. And this phenomenon is really triggered at puberty. So you are going to select what type of connection you want to do, and you are going to decrease the number of neurons. This is the estrogen, so that's a sexual hormone, increases in hippocampal dendritic spine density and synapse formation increases was I clear or am I cut again? No.
We can still hear you.
Okay. So you have during puberty, you have an increase in estrogen, you have an increase in all the different sexual hormone, as I explained, with the AMH influencing this synthesis. And you have at the same time an increase in dendritic spine density, synapse formation, axonal sprouting, and enhanced long-term potentiation in hippocampus. So long-term potentiation means that you are going to stabilize the synapse, and you are going to modify the different density of the neurons. So all that is influenced by AMH and by sexual hormone. Something to know is that the hippocampus and also amygdala are the function that the structure in the brain that are linked to psychiatric disorder, a certain type of psychiatric disorder, notably the depression, anxiety disorder, and schizophrenia. So what we know about schizophrenia is that it's proposed that the theory around schizophrenia is that there is an exaggeration of the synaptic pruning. And the synaptic pruning takes place during adolescence. And synaptic pruning is dependent on the AMH. So one of the issue having, I'm going back here, having the SMAD4 mutation, the AMH is not going to produce exactly what we want the hormone to produce, and it can act on the synaptic pruning, and that has been shown to be able to trigger schizophrenia. I don't want to say that Myhre syndrome patient has schizophrenia, but there are some cases of schizophrenia. They are not common, but that can be explained by the fact that you have probably a discrepancy between the synaptic pruning in people with a SMAD4 functioning properly and Myhre syndrome patients. The same with depression and anxiety. If you have in the hippocampus not functioning properly, then you can have also a problem with depression and anxiety. So I'm talking about hippocampus and amygdala because there is a high density of gonadal hormone. So the hormone I was talking about with the AMH. It's a bit complicated, so I hope you follow me. So that's the hippocampus and amygdala is going to be influenced by the AMH, the anti-Müllerian hormone. And in fact, in that zone of the hippocampus and that region of the brain, we see that there is a synthesis of anti-Müllerian hormone. So that's what I was talking about at the beginning, is that the anti-Müllerian hormone is not only in the peripheral system, but it's also in the brain and produced in the brain. So what we know is that the anti-Mullerian hormone increases the synaptic strength and plasticity in the hippocampal synapses. So if you have an impairment of this hormone, you can imagine that the synapses in this area of the brain is going to be modified. Something that is also important in the hippocampus at puberty is that you have all the GABA receptors that suddenly increase, and there are some hormones that are very influential on those GABA receptors, which is the THP coming from the progesterone. I'm not going to show you the whole chemistry around that, but that can be also influenced in a balance with the aromatase. So maybe I can show you back. So the AMH acts on the aromatase here, which will modify the production of androgen. And where was I? Here. And the THP is also in this whole group and balance between the different androgen and estrogen hormones. So that's also something important for Myhre. So that's just the hippocampus. But if you look at the other part of the brains, and notably the diencephalon, which is in the limbic system, it's really in the middle of the brain, in the center of the brain. You see that SMAD4 is really very important for that part of the brain and the different structure that are in the brain. It was shown that SMAD4 influence, I mean, it's even the astrocytes proliferation. So you remember I was talking about the glial cells that are fundamental for the neurons and for the brain function. The proliferation in adults, so I'm not talking about the child, but after puberty, SMAD4 is essential for the proliferation of the astrocytes in that part of the brain. So from the adolescence, then the astrocytes proliferation is going to be also influenced in that part of the brain. I already said that the AMH receptor pathway goes through SMAD4. That's the whole thing for today. And there is a central place, the structure of the brain, this diencephalon is central for autism spectrum disorder. That's ASD. I should have put autism spectrum disorder here. So this structure of the brain is important, the diencephalon, because there is the hypothalamus, which is an integral part of the endocrine system. That's what I was showing here. That's this part that's going to release all the different hormone and sexual hormone. That's the hypothalamus, but that's not the only thing. In the diencephalon, there's also the thalamus that assists with sensory perception, motor function regulation, regulating consciousness, sleep, and alertness. Then you have the epithalamus, which is just under it, and it aids in the sense of smell, but also helps regulate, again, sleep and wake cycles with the pineal glands that secretes melatonin. So if you have SMAD4 is essential for this part of the brain, for the astrocytes, and so we are going to see, we are checking for the microglia also. So if there is an imbalance in the signaling in this part of the brain, you can see that there will be a problem in regulating sleep and wake cycles. And wake cycles, this part of the brain is going to be really modified, greatly modified also at the puberty, where you have an inversion of the wake cycles. In fact, they have a tendency, it's not that they invert totally, between night and day. And the subthalamus is also here and is involved in the movements. But the most important is the hypothalamus and anterior thalamus that are part of the limbic system, and this is what we call the emotional brain. So together, this part, the diencephalon, where you see that SMAD4 is extremely important, and the hippocampus, where you see that the AMH is extremely important, those are the emotional part of the brain that are going to be modified at adolescence and really regulate the if you keep the equilibrium here, you are going to avoid all the discrepancy in emotional and psychosis. So do you have, I know it's very dense, it's a bit complicated, so I would like to open for questions and see where you have things you don't understand or related to your kids. I don't know if we are going to keep on the recording. So
Yeah,
open
I will
for
end the
discussions here.
recording so that folks maybe feel more comfortable asking questions.
Exactly.
Give me
Yeah.
one second.